First, we should know what is implicit function. I have taken an example. Is it possible to express y entirely in terms of x? If I try to do it, I get y is equal to 1 minus x square by x plus y. I cannot express y entirely in terms of x because this y is here. Similarly, if I try to make x express x entirely in terms of y, it is not possible. You can try that. So this kind of function is called implicit function. I'll take another example. Is it possible to express y in terms of x? It is not possible. If I try to do it, I cannot express y entirely in terms of x because this y is here. So what is implicit function? A function containing x and y is said to be implicit function if we cannot express y in terms of x or vice versa, that is x in terms of y, like the example that. Now I'll take this example only. Like I have to find dy by dx. I'll differentiate with respect to x. So first, each term has to be differentiated with respect to x. Now, since with respect to x there is no problem here, 2x. Here I am going to use product rule. X, now dy by dx. Differentiation of y is 1, so I have to write into dy by dx. Plus y, differentiation of x is 1. Now here, since we have to differentiate with respect to x, like differentiation of y square will be 2y. Since it is not x, I'll write down into dy by dx, and this is 0. Then I'm going to isolate dy by dx. All the terms containing dy by dx one side and the other terms the other side, and then I get dy by dx is likewise I can differentiate also with respect to y. This time I'll differentiate with respect to y. So d by dy. Now this is x. So 2x, I am going to write dx by dy because I am differentiating with respect to y. Here the product rule, x differentiation of y with respect to y will be 1. But here differentiation of x with respect to y will be dx by dy. Here no problem because with respect to y, and this is 0. Now I'll isolate dx by dy. Now if you compare the previous differentiation and this one, just the reciprocal. I'm going to use the product rule here. Differentiation of y is 1. I'm going to differentiate tan x plus tan x sec square x. Now all the terms containing dy by dx should be together. So sec x plus x square other terms I'll take it other side. This term therefore dy by dx will be equal to quotient rule. Two x and dy by dx. This will be cos xy, and here I'm going to use product rule, x plus y. Here y minus x I take LCM y square. So y square cos xy. This y square this side. All the terms containing dy by dx should be one side. Here I have plus dy by dx. So x y square cos xy minus x, and this will come this side. The terms that does not contain dy by dx. And finally I have by. This is the answer. This question is very important. I can write here x plus y by x minus y is equal to sec inverse A. Now this is constant. The starting is very important. And then we have to differentiate with respect to x. And since it's a constant, it will be 0. So here what we can do is, I'm going to use quotient rule. Now 0 into this is 0. So right here x minus y, differentiation of x is 1 and y will be dy by dx. 1 minus, and this will be 0. Now I have to make dy by dx the subject of the formula. Into 1 minus, simplification is very important, minus into minus is plus. This is where students make mistake. So I'll take dy by dx one side, x minus y, I'll bring this one this side, x plus y gets cancelled here, x gets cancelled, and finally I have two y, and then a final answer is proved. It's proved. Since on the right side you have only y, we are going to make x the subject of the formula and differentiate with respect to y. X is equal to y by sine a plus y. And then I'm going to differentiate with respect to y. Quotient rule. With respect to y, this will be only 1 minus y, differentiation of sine a plus y will be cos a plus y by sine square a plus y. And then finally, if I reverse it, I get the required answer. This is the proof. Here you'll find on the right side only y. X is equal to sine y by sine a plus y. I differentiate with respect to y. Differentiation of sine y. With respect to y, remember that. Y. The moment you get this, it should be a good sign. Cos y sine a plus y minus sine y the formula sine a cos b minus cos a sine b. It is sine a plus y minus y. We can write here since sine a minus b is equal to sine a cos b minus cos a sine b. And then finally I'll make it a reciprocal. By sine a. Proved. Now this expression I can write here tan x, but you'll find this expression is same as the whole expression. So I will write this as y because this is also y. You'll find this and the whole thing is same. After that, y square is equal to tan x plus y. Now I'll differentiate this with respect to x. Y square is 2y. This is sec square x dy by dx. Now I have to make dy by dx the subject of the formula. Proved dy by dx d into y square. It's an implicit function, so I write on here 2y dy by dx and here 4a. So I get dy by dx is equal to 4a by 2y, which is equal to 2a by y. Now I'll find dx by dy. That is y square is equal to 4x. I'll differentiate with respect to y. Here it was x and here it is y. This is 2y and this is 4a dx by dy. So I get here dx by dy is equal to, or y by 2a. If I multiply dy by dx equal to